This is Lecture 8D on probability density functions for Calculus 2. What we're discussing here is the probability density or function, or the probability distribution function. When we talk of probability, often we say the probability in more specific terms, such as the probability I will get a job, or the probability that you will have twins. These are not the questions asked by the probability density function. Instead, the probability density function gives a probability that, for example, the bus will arrive in the next 5 minutes, or the probability that the number of fish returning this year will be between 3,000 and 6,000. In other words, the probability density function, or the probability distribution function, gives probabilities for a range of values. To find the values that we were talking about above, such as the probability that the bus will arrive in the next 5 minutes, requires integration of the probability density function. We're fairly used to probability density functions looking like, say, the Gaussian distribution function. But actually, any function can be a probability density function if it satisfies two constraints. First, or two requirements. First, the function must be non-negative. And second, the integral of the probability density function over its entire domain must equal 1. So, for example, if I have the function f of x equals 2 times 1 minus x, with x varying from 0 to 1, this is a probability density function, or rather could be, because it is non-negative over its domain. That is, f of x is greater than or equal to 0 for all x between 0 and 1. And also, the integral over its domain over 0 to 1 equals 1. Let's look at another example. So this is the probability density function associated with the age of rental cars. So from some data, this curve f of x, which is second. Let me get the pen. Okay. F of x, which is my probability density function, is given by this red line. All right. The integral, that is the area under this red line between two values, say between 0 and 4, gives the probability that the age of the rental car is between 0 and 4 years. If I integrated between 0 and 6, that would give me the probability that the car I rented is between 0 and 6 years old. Right. So that's a more practical use of the probability density function. Along with this probability density function are two average values. One's called the median and one is called the mean. The mean is the average or expected value of the function. It is calculated as the integral over the domain of the probability density function of x times f of x dx, as denoted with the Greek letter mu. So mu is the integral over the domain of f, x times f of x dx. If this looks a little bit like a moment, it is. Okay, if you remember the lecture from the centers of mass, this is a moment. The next value associated with the probability density functions is the median. Okay, here's a median. We just looked at the mode, so here's a median right here. The median is the value of the random variable, in this case x. This is written with a capital M. I always denote it with a little m. Okay. And it is this value of x such that the probability, that is the area under the curve, under f of x, from wherever this is starting, for example, in this case it starts at minus infinity to m, is 1/2. The integral from m to infinity is also 1/2. In other words, there's a 50% chance that the value here, any value, is a 50% chance that any value is less than this, and a 50% chance that it is greater than this value associated with m. So that would be f of m. Okay. 50% of the values are less than, 50% are greater than. Okay, remember that the whole thing was 1. The integral over the whole domain was 1. So to find the median, we set up this integral. You can do it any way you want. From m to infinity of f of x dx has to equal a half, or, of course, you can't do it any way you want, but you could go also from minus infinity to m of f of x dx. And this would have to be 1/2. Either the yellow or the blue equals 1/2. So you carry out this integral and then solve for m.